I want to talk about moldable development, which is a new way of programming, that happens through custom tools built for every single development problem you encounter. Now, my name is Tudor Girba. I am the CEO of feenk. At feenk, we are focused on making systems explainable. And by this we mean either small or large, new or old. We think that software today is not as explainable for humans as it should be, and we think it has to fundamentally change. So moldable development came out of this preoccupation, which is a long-term focus and project. It's more than a decade of research and development. And we first, every time we talk about tools, we have to show it, not just talk about it. And that's why we have built a platform, which is called Glamorous Toolkit, which is an open source and free platform. And the goal of this platform is to show how this new way of thinking about software could look like. And that's exactly what I'll be doing today. I'm going to show you how this experience basically can look like. What does it mean to build, to work with software by building for every single development problem a custom tool? So let's start with the first problem. So here I see an inspector over a folder that contains some sources. So, for example, I can see here some JS file. I can take a look at it, and I can spawn it to the right, where I see another inspector, which shows me the code of that. And of course, also, for example, I see a package.json, because actually this is a React Native application. Now, in this package.json, how many of you work with React? Heard of React? Okay. So this one, as I said, it's a React Native application. But now, if I look at these dependencies, many times I want to know about dependencies, but actually exclude the things that I know about already. So, for example, if I look here, I can see this one comes from React Native. This comes from React Native. This one obviously doesn't come from React Native, right? So here, how would I go about finding all the dependencies from here that are not from React Native? Just think for it for a few seconds. So how would I go about? And this is a problem that fits on a screen of on a single screen, right? So I have all these dependencies going from here to here. I could read my way through it. I could say this is a piece of text I could read, and I can mark this manually, maybe copy it in a note, and build a list like that. That would be one option. The other option would be to do some sort of regular expression. I can see like a piece of text where I have multiple lines. The problem with that regular expression is that there's another part here somewhere with dev dependencies. And dev dependencies I don't care about, for example, when I think about the dependencies that are deploy. And that those regular expression would have a little trouble with. So how else could I do it? Well, in front of me I have a JSON. So because I have a JSON file, I could just go here and say, I want to parse this thing. And because here I actually am in a live environment, self means this object over here, and I can simply execute this, and I get a dictionary back. So now I see here, okay, this is a keys and value, and then one of them is dependencies. There are 41 of them, which means that I can go here and I can say at dependencies, and look at those. Maybe I want to see them as associations. I typed the wrong thing. Associate. If only I could type. Okay, I have associations. Now I have 41 of them. And because I have an array, I could go and select them. And I can say, give me those for which the key includes substring React. I can see those are probably related to React. And then, of course, I could go and reject those. And then I have my answer. So what did happen here? What just happened here? What happened here was that I had a question. And then I had some tools up to some point. I had a tool for the folder view. I had a tool for the editor. But then when I had the next question, I didn't have the right tool. So I could have just stopped right there and just adapted the tool I had in front of me and then start copying things around and do whatever the affordability of the tool does or allows for. Or instead, I could just simply ask this question: do I have the most interesting tool possible for my task? And if I don't, I can build one. And that's exactly what I've done here. When I've done here, I built a little tiny tool that gave me the exact summary that I was interested in, and then I could move on. And so that's the flow of moldable development. Now, let's see how else could it look like. So again, it's the same, we have the same problem here, the same system. And then of course it has things like components, right? So one of the problems that we encountered when we played a while, just to prototype a little bit with React, and within 2 weeks of playing with it, we came up with this circular dependencies problem. And you have circular dependencies between React components, and you deploy them, and you only find about them at runtime. And then say, oh, where does this cycle come from? And then we said, surely, this is the most used framework in the world. For sure, this is not an uncommon problem. And it isn't an uncommon problem. And then we said, for sure, there must be a tool that actually quickly shows us where those cycles possibly are. And then it turns out that there isn't. So that's interesting. What do we do when we don't have the most interesting tool available for the problem at hand? We're going to build one. So that's exactly what we did. So here we have, we built a little thing. And if we execute this, we get another perspective over the same sources. So one way to look at the system would be to just see files. But another way to look at it would be to simply say, well, show me a different perspective. So for example, here it shows me a model. And so what does it mean to have a model? For example, here I have the list of all React components. And what is a React component in this case? Well, it's just an anonymous function, right? Except, well, it's not just any anonymous function. It's an anonymous function that returns this kind of thing. And so not all anonymous functions are React components. So now it would be really nice, given that that's what holds all my logic of the application. It would be really nice to actually get an understanding of this flow at that higher level. I don't want to see and go and edit JavaScript, which is just the incidental syntax for React.js, right? Most interesting semantics happen at the framework level. So okay, this is one way to look at it, but back to our problem with the cycles. What we'd really want, we'd like to see the dependencies between all of these. And of course, there's just a perspective change over the group of components. And that's exactly what we see here. So we see here a list of the components and the different dependencies. And if I click on any of them, I can see, for example, here, the render button actually returns button, and therefore there's these dependencies. And this all can be, for example, in this case, we can statically infer this, and we can quickly go and find our cycles. And again, it's not a complicated problem, but it's an interesting one, because this is a very, very used framework, and most likely this is a not seldomly occurring problem. And yet, even for this, we don't have a tool that solves it. And the question is why? And the reason is because we don't really talk about these things. And I think we should, because there's a lot to gain by doing this. So let's move on. The question is, how do we, we saw all these views, but the question is, how do we create the views, right? So what's the flow in which these new things appear in our environment? So to this end, I'm going to switch gears, and I'm going to look at how we play with an API. So here I have a URL, which, if you go to https API github.com orgs feenk.com, that's our organization. I'm using here an HTTP client, and I'm getting it. Of course, I'm getting a string back, which has a JSON inside, which is great. But of course, I never want to look at a string. What I really would like is look at the dictionary, because it's much nicer. I can see here keys and values. But, this is not an ordinary JSON. It's a JSON representing my organization. So what I would really, really like would be to actually have here an entity, a first class entity. Let's say I will call it my organization. And I'm going to put in this entity this raw dictionary that I just got from parsing the string. And of course, this class doesn't exist, so I should go and create it. And of course, when I create it, I'm just right there in the flow, so I don't switch to anywhere. I'm still in my kind of notebook thing. So I have my organization. Then, of course, raw data doesn't exist, so I should go and create that. At the moment, I'll just simply store it in a variable inside my organization class. I'm going to put this dictionary in there. I'm going to define this as a slot, as we call it in this language. And then when I'm inspecting it, what do I see? Well, I see my organization has raw data. That's kind of interesting. But of course, it's not a lot in there. Let's actually take a quick look at this raw data here. I can see, for example, that somewhere here, for example, I have these kind of ideas, these kind of entries with underscore URL in it, like repos underscore URL. And if I go to repos underscore URL, I'll probably, actually, I don't know what I should do, so let's go and find out. So what I'm going to do here, I will say, well, I take raw data, so this variable inside this object that I'm looking at, and I have this notebook which is contextual to my object, so I can access its variable. So I say raw data at repos underscore URL. The interesting thing is that I can see it before I type it, right? I don't have to think things in my head. So then I have a string here, that's going to be a URL, obviously. Great. So I can say here URL is this. But you know what? I actually have done it before. I have this, once a URL is there, I can just take a JSON and parse it. Let's see what happens. Oh, indeed, it's a JSON lines. Great. Which means that I can also go and parse them. So I parse this, and I get an array of dictionary. Well, great. That's kind of interesting. Now, you know what? This is a nice predicate over here. It would be nice if I would promote it as a method in my new little interesting object. So I'm going to select this, and I'm going to say extract method. And I'm going to create this method called repos. And I can see what happens there. It's going to be this new method being created. And I can simply say OK here. And now, if I expand it, notice how the editor got a little triangle that allows me to expand this newly created method in place. So I can see, oh, look, it's already there. Great, which means that if I execute this method here, it's going to be created here. But now, actually, I would like to see this list here, because that list describes my organization. It's a nice view on it. So, OK, let's do that. And to this end, I'm going to switch to the view that shows me the class of the object that I'm looking at. And I'm going to say here, well, show me the repos for, and I'm going to pass here something we call view. View is like a, it's like a stream made out of widgets, basically, not strings. So here I'm going to say repos. And, you know, a list, the simplest thing you can build a list is simply say what kind of items go in there. And I already defined this in my little method here. Notice how the triangle appears also in this method that I'm creating. And as I'm creating this method, a new view appeared over here. Right? It's right there. So now, next time I'm going to inspect this my organization object, I'm going to have these my repos here. And I'm going to go, OK, but we should go a little step further. And the step further is, well, this is nice, but it returns me an array of dictionaries, which is, not so nice, because I don't like to work with dictionaries. I would like to work with my domain objects. So I'm going to do here, I'm going to say, you know what? Actually, let's collect here, given a dictionary, let's correct my repo. And I'm just going to pass this dictionary in and see what happens. Of course, my repo doesn't exist, so I should go and create it. Let's make it a little bigger here. It's already great. There's no relationship at the moment between the two classes, so I'm going to just define this one in place here, and then I'll say OK. And so now when I execute this, what do I get? Well, I get a list of my repos. So, which also means that now when I go and do this, I get a list of my repos. Now, of course, I could just quickly go here and say, well, let's change quickly the way this looks. And then we say, oh, actually, I don't know the way it looks. How should it look like? I don't know. So maybe I want to see it before I do it. So let's see here. Actually, there are lots of things here, right? But actually, luckily, because it's an array, it's a dictionary, I can actually search for it. I don't know. Do they have something like name? Oh, look, they have full name and they have name. Let's use full name. So I'm going to say here, next, put all, self. No, I'm going to say here, raw data at full underscore name. Was it like this? I think it was. Let's see. Did I get it right? I did. So that's the process. At this point, I just created a view and with an entity with the view, and clicking on that one got me to the next thing. Now, if I continue on this process, which is fairly mechanical, I basically could go to something like this. So I have an organization here, which shows me a repositories. Maybe it shows me the events. It's a different way to go and browse. But if I look at the repositories, I can go to this repository over here. Maybe I can see the events just for this repository, maybe the contributors. And I can click on this contributor and go and see the contributor and so on. So this is a different way. So what happened here? Basically, it's a process in which we can just go from something we don't understand and just gradually build our understanding, and then leave a trace of executable tools, which have a couple of properties. First of all, they document how you're going to go and use the API, because the API is not just the thing that you're calling, but actually what happens inside. What's the meaning of repos underscore URL, for example? But the other thing is that you actually get an executable documentation because this thing is executed. And the third thing is you actually get a tool to actually consume the data that comes from this API. So yeah, this is how the process through which we construct these kinds of tools while we work. And you notice here everything was fluent, so I didn't have to switch to any editor. One principle here is that we think that tools should come to us. We shouldn't go to tools. Now, of course, the question is, what's this weird language? Well, this language is actually it's a Smalltalk derivative. It's called, the underlying language is called Faro, in which we have implemented our environment. But what about other languages? So here I have a situation where we could browse GitHub, but in this case, through GraphQL. Anybody heard of GraphQL? Okay, a few. So, of course, GraphQL is interesting because, well, it's interesting. But if you have to use it, right, the question is, how should you use it? So, if you look at how it's marketed as being a tool that comes, it's interestingly self-described, and it comes with at least editors that give you interesting completion. And that's true, right? And you also have the possibility to go and browse the schema, which is exactly what we can do here. So we can see queries and mutations and so on. So for each of them, you can see what you can do with this. Okay, but let's do something that is more real. So a typical GraphQL query interface looks like this. I have a GraphQL query, and I have some parameters using JSON. And I could here, for example, I'm going to do exactly the same thing I've done before. I'm going to go and ask for the details, a URL and description for this organization called feenk, and the repository called Toolkit. Of course, here, one of the interesting things you can do when you think about interaction or integration and developer experiences is, let's say that from once in a while you want to rename things. Like this key in JSON, I want to rename it, and so then I also wanted to rename this at the same time. So that's kind of neat. But of course, when you want to do really interesting things, you want to do pagination, and if you want to do pagination, you have to add these little things here, right? You have to add this page info, and then you have to add the start cursor and the end cursor, and so these are like, things that you have to have in the query so they get populated so that you can use them to find the next page. And so here you can parameterize this one. In this case, we're looking for 5 items exactly for the same things. So I'm going to query this, and of course, looking for the repositories in this feenk login. And that's exactly what I get. I get 5 nodes here. with 5 of my repositories. Now, of course, to do pagination, this is where GraphQL stops, because you need to now combine it with something that actually goes and does the loop through all the pages. And the question is, well, how does it do it? And of course, a really integrated experience would like to have you do it in the same place. Typically, editors stop exactly at this interesting point. So I have another snippet. In this case, is in our language. And in this one here, we take the result that comes from GraphQL, and then we have a little paginator object that we can instruct it what to look for. And then once we do this, of course, it gets these 5 items. But when I look at the items view, right, I can see that it gives me it does the pagination to give me the items. And that's kind of nice, because now I can get to browse my data, right? I can have a way to quickly browse the data that I'm querying with GraphQL. So that's kind of nice. So we have this kind of integration. Notice when you have a place where multiple languages can meet, and you can break this barrier that otherwise can be kind of stiff between different kinds of languages. But we want to go, when you talk about development experience, you want to go a little step further. So this little thing here is kind of, I really don't want to write this by hand. So what happens if I don't? So here's exactly the same query, but without that boilerplate. So let's see. I'm going to do exactly this, and I'm going to expect this. And I say, oh, look, it worked. But why? And this is a reasonable question to ask. We are so used in engineering that our tools do magic for us. We often forget to ask the why. And also, it's also because these tools that we typically use are kind of black boxes. And I think that we should go back and revisit this ability that should be kind of pervasive in engineering, of asking why. So here, for example, we also asked, does this work? How does it work? How do we want to communicate this? So this object here, this paginator stream, that's kind of like a meta object that goes and does the pagination, not only shows me the items in the JSON string, which are the things that, like, at the immediate level, I have an object and I apply it, or I have some logic and I apply it. But it has another view here, which is kind of a meta view, right? And that's the interesting thing. It shows me a diff between the actual query and the query that was actually used. So there's a little algorithm inside that added this code. But it's up to me. I want to know what was actually executed versus what I have typed in, because that's kind of an important thing. And that's the interesting thing here. Another principle is that as soon as we think of something before we write the system, we believe that it should be the responsibility of the system to carry that view forward. So that's exactly what you see here. And the other thing is that most interesting problems in software engineering, they bridge different kinds of meta levels. They're not just on the same level. You want the information from here, and sometimes the information about the information, and so on. And so it should be very quickly, very easy, smooth to put all of these pieces of information together to favor the reasoning about systems. Okay, but what about other languages? Well, for example, here I have an example of a Python snippet. So here I have, it's just a variable with a file name. In this case, it's actually in Faro. That's a normal snippet. But here I have a Python connection that actually uses a pandas to read the CSV. And if I'm going to execute this, I actually get a Python object. Now, this Python object was actually defined here. I have this class movie and movie collection and so on. And they have exactly the same kinds of views defined. But now, in this case, they are not defined in our language. They are defined in Python. And so now here I have a movie collection. And when I look at one of those, I can see that there are different kinds of movies. And I can navigate my Python object, in this case, just in the same way as I was doing before. So this idea is actually not specific to a specific language. It's kind of reasonably generic. Okay, now, so far we looked at use cases that are pretty much about consuming something, so reading. And that's for a good reason. That's because we started by automating, we wanted to automate as much as possible the reading part. In fact, we think that reading is the most wasteful activity that happens today in software engineering. and most reading should actually be automated away. And then the way to automate the weight reading is by creating these kinds of custom tools. But it turned out that this idea of custom tools applies also to editing. So for example, here's the definition of the dependencies of Glamorous Toolkit itself, the environment that we're looking at. Now, of course, I can take a look. So you can see here this definition. It depends. There's like a fluent language here, fluent API that says that there's a dependency to this one, and to this one, and to this one. And of course, I can take a look at this, all of these dependencies like that, but it's a little bit hard to read. And we noticed that, and we said, yeah, this is, indeed, this is, if I take all the dependencies, and this tool here, I can just apply it to any map of dependencies described in this language. But specifically for our environment, we know exactly where the boundaries is. We don't care about all dependencies as long as we know, for example, these are the boundaries that we control versus the other boundaries, and versus the other things that we don't control. And all of a sudden, the view becomes much more intelligible and much more useful. It's the same kind of content, but with a little bit of pruning that only makes sense in our context. But as I was talking actually about the editing part. And so notice how here I have a triangle that appears next to this string. And that's because it allows me to expand just the method defining the thing that this string refers to. That's kind of interesting. And if I go and edit this, what's interesting about this is I can actually get completion inside the string. That's because my editor is also moldable. It understands the context that I'm editing based on whatever is around it, and I can define various predicates of how I want how I want to customize its behavior. And so that's how we think that it's also possible to apply the same principle, but also for the editing part. Now, of course, what about forward engineering? So here's an excerpt from the book that actually ships with the environment. There's a Harry Potter size book, Harry Potter 3 actually, we measured. Size book inside here, which is made out of lots of notebooks and executable examples. And here you see an actual game that we use as a tutorial for people to start learning. And it's one of those Ludo games where these things have to move around the board. And you have to move a 6 to get out of home and then do things like that, right? Now the question is, how does this appear here in my notebook? Well, actually it appears because I'm going to browse here the source of the snippet that produces it. And actually, this one comes from the source code. That's kind of interesting. So let's take a look. So I have here a method which is annotated with something called GTExample. And here I have it seems like I have a game, and then I'm doing some actions here, and I'm doing some assertions. So up to here, it looks like a test, right? Just setting up something, doing something, and then asserting something. Except that here, we are returning something. There's like a test that returns something. That's what we call an example. Because examples return something, I can also base examples on other examples. Now, the other interesting thing, because I can do this, it means I can also get to execute. Notice there are some buttons here that appear when I have an example. So if I remove these, or as I type things, these buttons disappear. So if I inspect this, I get my game object, right? And so here's the D, the previous state, and then I'm doing something, and all of a sudden D appears here. But the question is, how? And it's like nice to see the before and after, and I can maybe imagine what exactly happened here, that something rolled, some 6, and maybe probably something captured something, but I don't exactly know what. And that's not convenient. As soon as I don't properly see something, as soon as it's not comfortable for me, I want to stop and make it comfortable. But the question is why? How? Well, for example, take a look here. So imagine that my game actually has a history of these moves that just happened there. So I could take a look at this. Now, if I inspect a move could describe itself. And that's kind of interesting because that's exactly what happened here. This was the state that I had before, then D moved there, then A moved here, and the other A moved here, and D got home. Now, when I have this kind of representation, my brain is much at ease. But the interesting thing is that in the process of producing this tutorial, first time we did it with someone, they didn't create this entity at first. They only created the function. They wrote it in a TDD style. They created the functional tests, and they didn't create the entity at first. And so at the end, what happened was that we got this before and after type of view, but we didn't get the explanation. And then we did another iteration in which we introduced the notion of move. And then the system became more explainable because I had where to attach my view. And that's kind of interesting because it turned out that also this led to an immutable design. Before, the system was just changing its state, which is perfectly fine from the perspective of the unit test. That was just looking at the input and output. But afterwards, I had to remember these moves in order to be able to take a look at every step, right? So now I have a kind of a custom debugger, if you want, for my specific tool. Now the interesting thing is that once you have a custom debugger like this, we can also transform it into documentation, but not technical documentation. So for example, here I have a user and end user documentation about the game. If you think about it, like every game you open it up and then the first thing they tell you is what are the valid moves, right? So that's exactly what you see here. These are all the possible kinds of moves that are available. But these are not just drawings. They actually come from actual scenarios that the engine knows how to deal with. So the idea, again, is that this documentation is actually just a side effect of making the inside of the system explainable. And in this case, I took something from very deep inside how the game is working, and then I put it and promoted it into something that I can use to communicate with users. So non-technical people. Okay. Now, of course, I was just showing you all sorts of notebooks here. In fact, this is the page in which I have all the notes about this specific talk that I'm giving here. This is the code for my slideshow. But I also am prepared here with a few posts here. So here I can say you can only perceive anything in the software system through tools. So tools are essentials, but software is also contextual. So tools have to be contextual too. And what I'll do now is I'm already logged in on Blue Sky here. Blue Sky is a social network that actually allows you to communicate with it from the outside. And so I just post it. I have a notebook in my notebook, which is multi-language, and you can program it, extend it the way you want. I just transformed it into my own personal knowledge management tool. And then because I already have here a post, the next one, I'm going to just say here, YOW 23. And I'm going to post this. So now if you actually go to Blue Sky, okay, it's posted. Yes, so a different way it's kind of unexpected to see an development environment now turned all of a sudden into something that looks like a personal knowledge management. But here's another example of something that you might consider to be like a DevOps. Actually started here a server with a Docker server. And normally when I look at a Docker output, right, I see something like this. I see server, blah, 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 success, success, success. Anyone familiar with outputs like this? Right, a few. But I don't want to read text. Instead, what I would like to look at something like this. So this is much more interesting. Now, an interesting place here is to see this compose file, because that's what defines what goes in my Docker image. Except that this specific compose file is actually built on a little template that we have internally, just because we wanted to be flexible in how to create these kinds of Docker images. So again, we are back into this situation where I have some specification that I wrote, and the actual thing that actually gets deployed is somewhere else. So what do I do in that situation? For example, a diff view is kind of nice. So here on the left-hand side, we see the template that I wrote. And on the right-hand side, we see the logic of populating this template so that I can basically debug this. Again, a simple thing. But this view here It's not possible to, like if I go to my Docker, to the Docker interface, it will not know about my template tool. This view is only possible to create after I know my context. So, here's my question. What's the name of this tool? Is it an API tool? Is it an architecture tool? Is it a knowledge management tool? Is it a system documentation tool? Is it a DevOps tool? It's all of them, and really none of them. Because this way of defining tools come from more of a marketing perspective. Someone had the need to create a niche, so they defined a tool. But really, from an engineering perspective, it doesn't really matter in which bucket the problem fits. What matters whether or not the experience that you have in front of you is conducive to solving that problem that you have in front of you. And that's a change of perspective. And what you've seen here is, this is an environment that is, we call it a moldable development environment. And we see it as a language made out of interactive and visual operators that you can program and combine in many, many different ways to essentially create millions of narratives about your system. And because you can, once you can start to not be confined to these boundaries of the tools, you can also start to create surprising kinds of combinations. So let's go back to this blue sky thing. So here I have a snippet, in this case, not with posting on it, but with logging in and querying it. So here I have, I just logged in, and I'm querying my timeline. And I can see this is my timeline, and that's exactly what I just posted here. Right? That's the first post and the second post. And so that's kind of nice, because now I can go, for example, if I go to one of these, I can see that it knows that this is a thread, so it will know that it has this a reply to it. And then, of course, I can go to my followers and look at those as well. It's kind of what you would expect from a typical interface that you would have with the social media, except that this one happens in my development environment, in a development environment that I can control locally. In fact, it happens in the most basic possible tool I can have, an inspector. It's really, really basic. But because it happens in an inspector, I can also go and interact with it the way I really want. So, for example, one thing that I always do, or I'm always interested in, is I want to go back to the threads that I wrote. Right. So in the example here, I wrote two messages, but one is in the reply to the other one. So here I have a query, which goes and basically looks at all the posts that come from the handle, my handle, the current one, and that has a reply that actually comes from the same author. So if I execute this, what do I expect to get? I expect to get a list of messages that are on the top of each thread. But notice, because this stream knows how to present itself, it comes to me back in my own terms, in showing me these views, right? I see a normal timeline, but now it's streamed the way I want it to. So that's the interesting thing. It's a kind of surprising. You get surprising properties just by composing things that are otherwise disparate. Okay, but a more interesting thing is, how did we create this? How did we create this browser? So Blue Sky comes with is based on a protocol called the AT protocol that is defined in through a few JSON files that basically, so it's kind of self-described as well. And if I go here, that's the project that defines this the so-called lexicon. So all these entities that the API return, they are described in some in these lexicon JSONs. And so now I can go and browse these ones. So here I have an editor, which is now dedicated to just editing these JSON files. Now these JSON files are really kind of difficult. to read. So you can have here, this is the ID of this record, right? You have this ID over here. Then you have these references to some other things that maybe are coming from other files potentially. Then you have these other things inside, and so on. Now, of course, we should not, even if I'm describing it in a JSON, we don't necessarily need the editor to stay at the level of the JSON. So the first thing we see that you have these highlighted different parts of the JSON. But here, I can see that I have these little dots. And if I click on those, I actually get to see where they are being defined. So I get to navigate now, right? Because that's exactly what I want. It's just I want to be able to define a schema, essentially, and the schema needs to be well formed. So every time I'm using something, I want to know where it comes from. So again, this is a surprising thing because we wouldn't think of it as an editor for a language, but in fact it is, right? And here we have a basic, syntax, which is JSON, but looking at this JSON at the level of JSON is completely useless. We want to look at it at the level of this logical language that we have on top. So why is this important? Well, when we think about development, we typically think about the active part of building things. But when you look at what developers do, they don't write code most of the time. They read. And the reason developers read code is because the system holds the truth about what's going to happen or what happens with the system. And so they want to go and understand enough to make a decision about how to change it. There's always this intent of making the change. And so we call this is called decision making. Now, given that this is what occupies most of our time, it should follow that we should optimize software engineering, not so much for writing, but for reading. And the question is, how do we do that? Well, to do that, I'm going to use a wordly map. Any of you who know what a wordly map is? A few hands, very good. So a wordly map gives us some tools to go and reason about the evolution of concepts or ideas over time. And so here on the left-hand side, we have Genesis, which is things are very prototypical, done purely manual, unrepeatable. And on the right-hand side, you have commodities, which are completely, basically automated away. So typically, both business and developers, any question we have, any challenge we have about a system that requires some sort of a decision should be based on information. Now, currently, this information about the system is built out of manual views. Every time you describe your system on a whiteboard, that's what you're doing. You're manually creating a view about the system. But whenever that happens, you're actually not documenting the system, you're documenting your belief about the system. So these manual views are actually gathered with manual inspection. And the reason why this manual inspection happens is because the tools are very rigid. The tools we have in front of us, they are static. So it's hard to change them to fit the context. Now, of course, we don't want these manual views to be put together manually. We want to generate them. And the way we do it is by basically transforming this effort of manual inspection into specific coding. So we take a little time to create these little tools as we go along. And of course, to make this practical, we need moldable environments. So environments that make it really, really inexpensive to create the next iteration of the tool. And ideally, we want to make it so inexpensive that the cost of the tool is amortized on the first use. That you don't need to use the tool twice for it to make sense. And that's what we've done with Glamorous Toolkit. We showed that it is actually possible to make this work. But there's another dimension to it. The other dimension to it is that there are different kinds of skills that are involved in moldable development. There are at least two. And one is here on the top, we're talking about the stakeholder role. This is the one that knows how to formulate the problem and transform it into action. And here at the bottom, we have the facilitator role. This is the one that knows how to translate some sort of a question into a tool. These two roles could be handled by the same person or by two different persons. That depends on the scenario. But it's important to know about these kinds of skills because you train them differently. So, we built Glamorous Toolkit to show how all this can be practical. But really the interesting thing is not the tool. The interesting thing is what you do with it. And in the end, our goal is to start a conversation. We want people to start talking about how they go and understand their own systems. Because we believe that the inside of software systems are holding the greatest wealth on earth today. And today we just keep treating these systems as black boxes. And this is not exactly how we want to live our lives, because we keep building up black boxes over black boxes with no hope of understanding what's underneath. And we believe this is actually attainable if we start optimizing for it. Now, Glamorous Toolkit is free and open source. You can go to gtoolkit.com, download it, and you can go and use it to practice it. But it's also a very extensive case study. You can actually go and learn from not just you by using it, but from how it is built. So, for example, here is a visualization of all the extensions that already come with the platform built in, basically. And these are tools that we have used to build the platform itself. They were engineering tools that we needed along the way. Thank you very much.